All right, this week we're going to be talking about properties of exponents. But before we get started, we want to make sure we understand exponents. All right, when we deal with an exponent, we have what we call a base, and then we have an exponent. All right, so this is read a to the n. A base is an expression that represents repeated multiplication of the same factor. A power can be written in a form using two numbers, a base and an exponent. An exponent is a small number or variable in the upper right-hand corner of a base number or variable. Sometimes the exponent is called the power of the term or just power. Remember that an exponent is just a shortcut to multiplication, just like multiplication is a shortcut to addition. The exponent tells you how many times to multiply the base by itself. For example, 3 squared can be written as 3 times 3, which we know is 9. Or we can look at this example here, where we have 7 to the third power, which can be written as 7 times 7 times 7. Don't forget that the dot just means multiplication. So, down here we have, it says write the following expressions in expanded form. We have g times g times g times g times g. Note that we see g 1, 2, 3, 4, 5 times. So we can write this in exponential form as g to the 5th power. All right. So when we get to the next one, we have x times x times x, y times y times y times y times y. Now we see x 3 times, so we can write that as x to the third. And then right beside it, we're going to write, we see y 5 times, so we're going to write y to the 5. And this is our exponential form. Note how x cubed, or x to the third, and y to the 5th is written side by side. That just means multiplication. All right, now for the next part, it says write the following expressions in expanded form. Note, a to the third, b to the 4th. We can write this as a times a times a, and then we can do b as b times b times b times b. All right, we wrote a 3 times and b 4 times. All right, now let's try x squared. Not just x squared, y squared. So x squared, y squared can be written as x times x times y times y. We multiplied x twice and y twice. And this is the gist of what you need to know about exponents. Now let's get to the first rule of properties of exponents, the multiplication rule. All right, to multiply the following examples, first write them in expanded form. Then count the number of bases that are the same. The number you counted will be the combined exponent. All right, so we have here in the first one, 2 squared times 2 to the 4th. All right. The expanded form of that would be 2 times 2, right? That's the 2 squared part. And then times 2 times 2 times 2 times 2. That's the 2 to the 4th part. And now we have to count our bases. So we have 1, 2, 3, 4, 5, 6 2's. So this can be written as 2 to the 6. All right, so let's go to the next one, where we have x cubed times x to the 5th times x squared. We can write this as x times x times x, and then times x times x times x times x times x times x times x. So this is representing right here the x cubed part. This right here is representing the x to the 5th part. And then this is representing the x squared. They all have the same base of x, so we can write 1, 2, 3, 4, 5, 6, 7, 8. And I'm just counting right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Since those are 10 x's, we can write this as x to the 10th power. All right, and we can do that in the next example as well. But notice here that we have more than one base. We have 5 cubed, a cubed, 5 squared, a to the 4th. Okay, so this will be a little bit different. We have 5 times 5 times 5 times a times a times a times 5 times 5 times a times a times a times a. All right, how many 5s do we see? Yep, 5 of them. So we can write this as 5 to the 5th times how many a's do we see? 1, 2, 3, 4, 5, 6, 7. Perfect. So this will be written as a to the 7th. All right, I want you to take a second and try 4, 5, and 6. And we'll go through that in class. All right, I want to get down here to where it says, do you notice a shortcut? Maybe you have. I'm not sure. But if not, go back and see if you can notice the shortcut. And here it is. You can add exponents of like bases. All right. So it's called the product of powers property. All right, when you have the product of powers property, let's say you have a to the m times a to the n, then all you have to do is keep the base and add the exponents. All right. So now it says try using the shortcut to simplify these expressions. So we have negative 3a squared b cubed times 5a b to the 4th. And we're going to use the shortcut, but first we're going to rearrange this so that we put all like bases together. For instance, negative 3 times 5. And then we're going to say a squared times a. Remember, that's just to the 1. And then b cubed times b to the 4th. So we just put all the different bases, and this is not even like bases, so I won't do that. All right, we'll put the like bases together. All right, so what's 2 plus 1? We know that's 3, so that's a to the 3rd, and 3 plus 4 is 7, so that's b to the 7th, and negative 3 times 5, we already know, that's negative 15. So our final answer here is negative 15 a cubed times b to the 7th. And we're going to do the same thing for 8. That'll be 2 times negative 3 times a to the 1 times a to the 1 times a squared times b to the 1 times b to the 1 times b to the 5th. 2 times negative 3 is negative 6. And then 1 plus 1 plus 2 is a to the 4th times b to the 7th. Because we added 1 plus 1 plus 5. And there we go. Number 9 is a bit different. Why? Because we have addition inside this parenthesis. And therefore, we can't just pretend that everything is multiplication. We have to apply what we call the distributive property. So this will be negative 6x times x squared. Negative 6x times 5x. And negative 6x times negative 9. So again, negative 6x times x squared plus negative 6x times 5x, and then minus, I'm going to kind of come on another row, negative 6x times 9. All right, hopefully what we notice here are the different these are different terms. So we can write this as, I'm going to write this in black, negative 6x, 1 plus 2 is 3. And then negative 6 times 5 is negative 30. So it becomes minus 30x. And then 1 plus 1 is 2. So x squared. And then plus 6 times 9 is 54. And then just x. So this is our final answer. Negative 6x cubed minus 30x squared plus 54x. Now this is a whole lot different than what the other ones. But it's something that could happen and we need to know how to do. But this would be more of an outlier. So don't worry too much. And now we're going to talk about dividing exponents.